Without further ado, I think it's just about time for Dr. Mohanty's presentation. Dr. Mohanty is a fellow of the Royal Society of Canada, the American Institute of Chemical Engineers, the Society of Plastic Engineers, and the Royal Society of Chemistry from the UK. He is the director of the Bioproducts Discovery and Development Centre, as well as a professor and the Ontario Agricultural College Distinguished Research Chair in Sustainable Biomaterials at the University of Guelph. And my experience with farm plastics, working at the OFA, is I get two questions asked to me all the time. What can we do with all the plastics we generate on them farms? And why can't we find something that will help us not use plastics and use biodegradable materials? So good afternoon, Dr. Mohanty, and thank you for joining us. And I will turn the presentation over to you.
So as you can see, the title of my presentation today is Biodegradable and Compostable Bale Wraps for Ontario Agriculture. And for everybody's knowledge, this is a OMAPRA Alliance project just funded, and this is just, we are continuing year one of this ongoing 3-year project. So what is the next one? Okay, then, so key points, what I'll be presenting today. First of all, I will give an overview of R&D activities at the Bioproduct Discovery Development Center at the University of Guelph. So many of you might be aware, but I might talk briefly what are the research we do at our center here at Guelph, and why to care climate change. And plastic waste is a daily news headline today, and there is a lot of news and coming of plastic ban, all those type of things. And categorically, I will talk sometimes of the waste plastic in agriculture and how to use the circular economy to make it waste-free world, and particular reference to waste plastics. So there are two parts of my presentation. Number one is existing bale wrap waste in Ontario and what are the value-added uses can be done, and what are the next stage of innovation, why progress of biodegradable bale wrap is required at this context, and whether that can solve the ongoing plastic waste as well as bale wrap waste and other type of waste in our agriculture. So before going to enter into the real subject, so let me introduce very briefly what this Bioproduct Discovery Development Center at the university, what we do. So our main target of the center is to circular economy driven R&D. We try to tap the waste and try to integrate into the plastic and make some value-added applications. The innovation of bioproducts in mitigating climate change is the main focus of the R&D activities at BDDC. So we create some novel bio-based materials with a focus to have a low carbon footprint to reduce old carbon and introduce new renewable carbon. So with a hope to reduce greenhouse gas and supporting the circular economy. So the concept is nothing is waste, waste is a resource for a new industry. That's the main focus of the R&D at the center. And bioeconomy, sustainability, there are other research we also continue. So if you look into the various raw materials we use to make new materials or innovative materials, so basically our raw materials are focused mostly on agro residues, forestry waste, and food industry waste. Those are the lot of waste we are getting, billions and billions of dollars waste, and we try to tap those and use as a new source for another industry. And if you look some of the examples of agro residues, I have shown some figure, whether corn stalk or grass or corn cob, few examples. Chicken feeder is a food waste. Co-products from biofuel industry, even the waste plastic from the waste end, some forestry resources waste, and some other food industry waste like coffee sap, tomato skin, all those. So those are few examples of the various waste we try to find uses in our new materials application. If you look into the application types, we have virtually two types of industrial applications. If you see to the left-hand side, we look into some automotive parts or consumer products. So here are some of the examples of the automotive parts which is already been commercialized in the Ford part. I will talk very briefly about that. Some consumer products we also commercialize by taking some waste plastic or recycled plastic and combining some grass or agro residues to create some consumer products like bio bean as well as some flower pot. If you go to the righter side, just I want to make aware that we do bio-based, non-degradable, recyclable, and durable bio-based materials. So everything need not to be biodegradable. So everywhere we try to tap the biofillers or bio waste to integrate into our new materials, which is commercialized yet and some other research still going on. If you look to the right hand side, we have also another focus to develop some biodegradable material where we believe the recycling is not a option or difficult or is not commercial, not is difficult to achieve. So in such type of applications, we target our research for biodegradable or compostable materials. So some of the examples are espresso coffee pod. I will give you an example. So these are the biodegradable products we develop. Some vegetable packets which has a very shelf life. So you take some, let's say mushroom packet and in a black pot and it just stays for 1 week. Then we throw that. And there are some black bean available in the market that cannot go for recycling. So those type of things we try to develop with the biodegradable alternatives. Just like tomato clips in the greenhouses, biodegradable straw. This is another compostable coffee pod we commercialized, and this is the right-hand side is some biodegradable film that I will be talking today in one of the biodegradable Bale wrap is also a part of our overall biodegradable film type of applications. So this is what why Environmental Minister of Canada announced on October 27 the ban of plastics is very likely to happen in 2021 because of climate change and all carbon tax and reduced greenhouse gas. So if you look into the left-hand side, there are banned single-use plastic or plastic grocery bags that's made from polyethylene type of things. Same polyethylene type is used for your Bale wrap applications. That's what I will be talking. Straws is also banned, tire sticks, six-pack rings, plastic cutlery, and takeout containers. So those are some of the very targeted plastics that have been diagnosed by the Canadian government to ban, but the hope is that many of the plastics might be banned slowly and steadily. It is not only Canada or in North America, United Nations, Germany, China, India. So those type of plastic ban has become very prevalent. So many industry are very vigilant and quite active now in developing some biodegradable alternative where recycling is not possible or not cost competitive, or that's the way people are moving forward. Those are some of the things I already told: barrier packaging, vegetable packaging. Those we developed in BDDC, and right-hand side, the ongoing projects, biodegradable film we are developing at BDDC for agriculture, just like Bale wrap, mulch film type of things. So those I will talk more as I move on. So why this biodegradable or bio-based materials is important? So if you look into this slide, I want to talk very briefly that in the left-hand side corner, I told our population is increasing and we have a fixed area in the whole world. So we are going to make about 9.7 billion population by 2050. And we don't have that much of resources to feed the people. And so what's the solution? So explosion of population, urbanization, we need new resource, and we cannot create new resource because we have a fixed area. So that means the resource need will be 2.5 times whatever now resource we have in the world. That is the critical point. So another point I want to tell you, I will be talking more about plastic waste here. You know, you'll be surprised to know we are creating about 300 metric ton of plastic waste per year, which is equivalent to the weight of the entire human population in the world. So it's not a small waste. It is really a concern throughout the world, and all are thinking around how to get value of those waste plastic or how to eradicate these plastic waste wherever possible. So plastic pollution ends up in world's ocean. So it was a 8 metric ton, million ton of plastic already entered into the world, but now the very recent statistics tell it is about 12 million metric ton of plastic has already entered into the ocean. So one truck of plastic waste per minute we create, and by 2050 we'll have more plastic in the ocean than fish. So 1/3 of the food is wasted per year, which cost about 750 billion, and that also are 8% global greenhouse gas. Another fact is that in each second waste to environment, for example, we inject about 10,000 plastic carrier bags in each second to our environment, one garbage truck of textile wasted for each second. So you can well imagine how not only the plastic waste, the food waste and other waste has become a critical attention of the world to find their uses and to eradicate the waste wherever we can. So here are some of the facts about the plastic waste. People make a lot of rational type of activities and arguments. Not only arguments, they also give opinion that recycling plastic is the one way to move forward. And thus that is certainly recycling of plastic is certainly one of the innovation to move forward. A lot of things will go forward. As I already told, we have produced more than 6.3 billion metric tons of plastics. Out of all those plastic that is wasted, all waste plastic is staying in the world. Out of that, only 9% is recycled, 12% incinerated, and 79% is landfill. So you can well imagine, although there are some recyclable plastic, and in the true sense, they are not really recycled. So I will give you example. So PET bottle is a plastic bottle. So all the waste of that PET is the very easiest plastic to collect, but only 19.5% of the waste PET is collected now, 19%. And high density polyethylene, only 10% of the whole waste is generated. Polyvinyl alcohol, only 0.9 billion kg, which is only 0%. There is no data that whether polyvinyl chloride is recycled or not. Low density polyethylene, same thing that we are making Bale wrap today. And whatever waste polyethylene being created in the world, only 5.3% is recycled. Polypropylene, only, which is a very well-known recycled plastic, 0.6% recycled. Polystyrene we use for food packaging or all those, only 0.9% of all polystyrene is recycled. And there are many cases we don't have any data whether they are really recycled or not. But something is recyclable, but what really recycled, that's a two different thing. Yes, with the current scenario, this recycling technology, people are trying to make a lot of innovation. I also do some research on recycled materials, and I am also very supportive of recycled materials. But if you see the current scenario, which is more than 50 years technology, recycling technology. So if you look into the real world, only 9% of the all waste is being recycled, and more than 80% of all the plastics are entering into the landfill. So this is a real concern of the whole world. And another biggest issue has coming out, microplastic. Those plastics that are being wasted, that enter into the in your environment, whether it is a river or agricultural field or whatever might be. There are various sources of plastic waste, whether plastic bottle or net or dress or whatever, and they create some microplastic. What is the definition of microplastic? Which is less than 5 millimeter in size, and sometimes there are nanoplastics also created with the passage of time, whose size is about 1 to 1000 micron. So it is a very busy slide, but what I would like to highlight here, microplastic detected in even the fish, chicken, table, even the agricultural plastics, which is also create this type of microplastic in the field, that also enter into our food chain. That has already been investigated and undergoing research throughout the world. So it is industrial microbeads, plastic waste dumped, and these are the sources of microplastic, which is being really a concern to many people. Through fruits and vegetables, microplastics are also injected. So it has been studied 80 gram per person per day that we are consuming microplastics. So microplastic intake in Europe and America varies from 518 to 3078 particles per year. That's basically coming from your fish. So those are few statistics. So those type of another issue. Forget about plastic waste, but we are moving more towards the microplastic or nanoplastic, which is degrade. They are not really biodegradable. They are breaking down, and that's not going away, and they are staying and entering into our food chain, which is creating a major health hazard, and people are quite conscious and serious about those plastic pollution. So, and here is a few the facts. So far, Bale wrap waste in Canada, agriculture generates 45,000 tons of plastic waste, and bale and silage wraps share about 30% of agricultural plastic waste. Currently, about 15,300 tons of bale and silage wrap waste produces per year in Canada. The waste plastic can be processed or co-processed for value-added products. So although those are the real concern, but still some research and some people are trying to take the waste plastic and they're trying to get some value-added application. Even in the BDDC, we do that. Not only biodegradable, but we also try to do some research and find some innovation, how to use those bale wrap plastic waste and get some new applications. Although biodegradable plastic is not going to happen tomorrow, but it takes some time for real world applications, but we will still have some plastic waste, and what are the immediate solution to utilize those waste and get some new applications. So bale wrap in Ontario and its impact. So this is what I did some research. Ontario agriculture generates around 7,267 ton of plastic waste from plastic films, including bale wraps each year. Bale and silage wraps contributes about 3,510 tons, and 3,125 tons is sent to landfills or open burning. And whatever this is not my research, I have referred some of the literature I have followed in this statistics. 60% of this is going to landfill and 40% on-farm open burning. That is what the bale wraps waste concern in Ontario now. Environmental impacts of those plastic-based waste: 3 tons of carbon dioxide equivalent per ton of plastic-based waste. That is another statistics. Recycling avoids, if we can make recycling, it can avoid 3.26 tons of carbon dioxide equivalent of plastic waste. That's the studies had been done by many established research organizations. So coming to the research, what we want to do here, there is a lot of science and development we do, and we try to make a lot of composite materials, in the sense we take from biomass, mix with some plastics. Those plastics might be recycled plastic, that might be biodegradable plastic, and always we try to use some wood straw or corn stover or miscanthus And we try to integrate into various plastics, not only those agro residues, as well as recycled fibers, recycled plastics. And we use some grape pomace, baggage, lignin, various types of waste, and try to mix those. And once you mix some dissimilar materials, there is a lot of this hate among those to mix well. Unless they mix well, we cannot create a product of commercial value. That's why a lot of science and fundamental research are undergoing, not only in our center, but throughout the world, who are interested in this type of biocomposites or biomaterials research. And that is what we try to do, some research how we can improve their compatibility to make some biomaterials of commercial value. So here is the first part I would like to tell. It is a side project or ongoing project in BDDC. Here what we try to do, we collected the waste bell wraps from Ontario, and thanks to Don Knott who quite favorable, and we could collect some bell wraps with the help of Dr. Mahendra Thimanagari of Umafra, and support from Don Knott of Knott Farms. So we collected those type of waste bell wraps and tried to do some processing in the pilot scale in our laboratory here. You can see in the left side, this is the waste bell wrap. So we feed it directly into our extruder machine. That is, we have a specific machine. And you can see the third figure, we are getting some plastic strands. And those plastic strands have been sent in the left-hand side. The strands, some researcher has put the bell wrap strand, and then we palletize those and created some recycled pallets made from Ontario bell wrap waste. So those waste we also combined with some natural filler. One example here, some agave plant, because that was something that Ford was interested to include some agave plant because there is no smell there. So that is the main reason. But this can also be implemented with other agro residues. That research is continuing. And we really developed some good mechanical properties by utilizing those bell wrap and natural fiber and make some biocomposite. That is also another innovative research that we are working here in BDDC. And here is another research. We combined the Ontario bell wrap as well as some plastic bottle. So plastic bottle is also not available. So we try to get the complementary properties of Ontario bell wrap that is made from LLDPE. LLDPE is a polymer that's called linear low density polyethylene, and PET is a polyethylene terephthalate. Those are two different plastics. We try to combine two different waste plastics to get, because the LLDPE, which is the waste bell wrap, it has a very good, one of the properties, like impact properties, is very, very high. So we try to take the positive property of this waste bell wrap and also mix with PET. PET has some another positive point. So we try to mix those, and after that we try to make some pyrolyzed biomass and try to make some composite materials. So we made some reactive blend. Blend means we want to mix in the melt stage, just like we are cooking and taking our food. So in our engineering type of research, we try to melt the plastic bottle and melt the LLDP and combine those and make a new plastic. So then we after that we try to make composites with some biomass, like waste biomass and pyrolyzed waste biomass, to make some new different materials. So that is an ongoing research project. That means one aspect is take the ongoing waste that is still going on, then move to our new innovation for biodegradable plastic. That's another research we do under this project. So we do a lot of pyrolysis of biomass and waste and thermochemical conversion from agro residues or agro waste. And I think you had one presentation on biochar, but our idea of making those char or modified biomass is to utilize those as a filler materials in the plastic to reduce the overall cost of the final product. You know, bioplastic is costly, am I right? So in this particular bell wrap biodegradable project that we are undergoing, Thank you, OFA, for their support. The idea of pyrolyzed biomass is to in making submicron biopillar, because if you take the direct biomass, you cannot make a very submicron filler. That we cannot go for film application. But that's the way we are pyrolyzing those and making a submicron biofiller to integrate in the costly biodegradable plastic. So that helps us to reduce the overall cost of the resulting film. That is a part of the research that we are working on, this biodegradable polymer, biodegradable Bale wrap project. So I told first how we are using the current waste of polyethylene and finding the value addition. And the next, in the biodegradable Bale wrap project, we are trying to make it cost competitive by addition of agro residues into the biodegradable plastic, with a concept that how we can make a cost competitive biodegradable Bale wrap. So here is we have a huge research program in our center. We take various biomass and we convert to torrefied and carbonized biocarbon. What is the meaning of torrefaction? Torrefaction means is a comparatively low temperature heating of a biomass in absence of oxygen. That's called torrefaction. So if you can, that is the raw biomass. This is a few examples, but we deal with more than 20 to 30 different waste biomass, like even chicken feeder and other food waste, including some agro-based biomass. So we got various yield of those after carbonization. It might be sometimes we get 80% and sometimes we get 25%, and we try to mix and that go for various applications. Those type of biomass conversion we are using not only for biodegradable formulations but also for our composite applications, for automotive and structural applications. So this is a broad research program going on. So both for durable and biodegradable formulations, we try to use those with a hope that our final formulations can be cost competitive, and also not only cost competitive, that also gives some good engineering property required for that application. So I will give one example here, how we utilize those waste biomass and create a commercial product. Here, I think many people might have had. So we created a biocarbon technology, patented technology at our Bioproduct Discovery Center. We use some biocarbon made from, although Ford use the biocarbon made from coffee shop, but that technology covered the biocarbon from agro residues and other food waste. And now currently Ford is implementing this technology, trying to implement to use for various other different parts. And this particular part that they are already used, if you see the top one, the Ford Lincoln in 2020, they used this part. And if you see the right hand, the real car that is already used, this is the headlamp housing. The housing of that, which is a black color headlamp housing, which is inside the car, but here are the real car, you are seeing the headlamp. So it's a headlamp housing of the Ford that was made from the technology developed at the Bioproduct Discovery Center. So highlights casing developed at the BDDC with the help of Varroc lighting, competitive green technology, and Ford collaboration. According to Ford, the resulting components from University of Well technology is about 20% lighter, and this part requires 25% less energy during the molding process. So these two parts constitute about 2 kilograms of the car. So that is one example. So now this technology they want to use in various parts of the car. There are there are a lot of small, big, medium-sized parts, and some other parts are going to be tested for implementation of our biocarbon technology. So far as this Bale wrap project is concerned, so one of the point is the recycling agricultural Bale wrap. Yes, that is certainly is a feasible technology. Plastic contamination of our Bale wrap creates some problem in real recycling facilities. Certainly, recycling is an important pillar for maintaining sustainability. Collection of those Bale wraps, which is currently in Ontario agriculture, and cleaning those and making the recycling. That is also another critical point to maintain a cost competitiveness of this recycled plastic. So conserving both material energy to diminish the outflow of greenhouse gas, certainly recycling is a good option. In Ontario, more than 3,500 tons per year of plastic agricultural waste is generated, including 6 million pounds bell wraps and silage made of linear low density polyethylene. This bell wrap we are using by our Ontario. This is made of a polymer, that polymer called LLDPE, linear low density polyethylene. Bell wrap LLDPE has a very excellent property. Those waste can be tapped, can be recycled multiple times. That's another point. But how cost competitive it is, that's another point. In BDDC, still we continue. Can we get some more innovation to make it more cost competitive? Recycling of LLDP from bell wrap in BDDC at the University of Guelph. That's also another project we are running. What is the summary of this bell wrap project we found? Recycling. Options for farmers to send agricultural plastic waste for recycling are correctly very limited. Banning. Most agricultural plastic waste are either sent to municipality landfill sites or burned, stockpiled or buried on the farm. That's what our research tells. Disposal. Cost of disposing of plastic bell wraps and other plastic products have increased, causing an additional burden to our farmers. And these they also create microplastic. Microplastic found in farmers' field could end up in our food. Possible solution. Biodegradable polymers can be used to solve the above problems, but the cost is a concern. Even biodegradable plastic has also concern. Number one, cost, again the disposal. So those are also the concern, and that also need to be innovated. And here is the project, the bell wrap project, that biodegradable bell wrap project we are working in our center. You can see what are the target of our of this particular project. It should be compostable. It should have certain barrier because it should be water resistant. It should have a high elongation. And we in our research we are taking various biodegradable polymer bands, Nobel compatibilizer, and in order to make it competitive, we are mixing like waste starch as well as some agro residues, waste biocarbon or pyrolyzed biomass or purified biomass to see how much waste materials we can include, and then develop some biodegradable plastic. That's the research that we are moving on in this project. Till now it is around 1 year, and it's a pandemic time, but still our research is moving in the right directions. So development, what are the objective of this current project? Development of high melt strength, super tough and compostable bioplastic blend film as alternative for existing non-compostable polyethylene used as bell wrap in the farms. Because we believe the current this current LLDP type of plastic, although is recyclable, recycling is becoming a concern, collection is becoming a concern, and more than 85% of those are still entering into the landfill. With that motivation, we thought this might be another innovation. Can it be possible? Inclusion of agro-based hydrofillers, waste starch, and biocarbon is another research target of this project that we are doing to maintain a cost competitiveness of such bell wrap that we are developing. So a lot of research are undergoing, polymerization blend, making composites, and various processing we are doing. I will show you in some of my slides. And finally, we are also doing some biodegradable test of our bell wrap and exploring the opportunity using the developed farm, the real field application as we develop in our project. So that's a ongoing research. So here are some of the facilities we are using for this biodegradable bell wrap. This is a processing facilities where we are mixing very biodegradable polymer and various plastic like biomass, modified biomass of some waste starch, and making some polymer blends based sites. And in our center, we have recently established the facilities because bell wrap type of project make a film. So these are film type of facilities we developed at the BDDC. So this is the large scale production facilities of BDDC, and we are utilizing these facilities for this biodegradable project applications. Here is some of the baseline experiment we did to develop some film. It is a plastic film. We just at the initial stage of research, we are experimenting various experiments to see. It is not only making a film, then you have to measure the properties, again go for compostability, again return back and re-optimize your research to see whether we are getting the required properties required for Bale wrap type of application. So this is also black color, some of the film also we are developing to see if that can be more cost competitive, and by addition of some biofiller, pyrosidized biofiller into our film formulations. Not only that, we do have some facilities in our center using biodegradable Bale wrap project. We are using this biodegradable facilities in center to determine the whether they are really biodegraded under the composting condition, because there are a lot of misconceptions about biodegradable. All composted products are biodegradable, but all biodegradable products are not composting. So biodegradable itself does not make any sense unless somebody tell what is the environment and at what time they degrade. So biodegradability, if they are degraded 90% and above within 6 months, they comes under composting biodegradable type of materials. Although in the laboratory you do it, but we need a certification from the third party to prove that they are really biodegradable product. Not only we do composting experiment because of the lot of concern about marine degradation, we have also developed a facilities in the bioproduct center. We are creating a real marine environment in our laboratory and putting our all developed material, whether it's a coffee pod or Bale wrap, and studying its degradability under marine environment. What is happening if in case that is entering into the sea? Is it create some microplastics or not? Whether they are biodegradable or not? Those are the ongoing research in this particular project. So further ongoing R&D for this particular biodegradable project, polymer matrix designing with hybrid waste starch and biocarbon. And we are making various film processing in the sense whether cast film or blown film to develop those type of films. We do a lot of characterization, and that is it was very good melt strength. This should have a good strength. This should have the appropriate barrier because it should need a water barrier because it will stay outside the field for 1 year. And disintegration or biodegradability evaluation, enhancing the circular economy by reducing use of petro-based plastics, and make a field trial. I think that will undergo the field trial once we are successful in making the real material. Then only we'll go to Bale wrap field study. Hope it might happen during the 3rd year of the project. So that is what some of the ongoing research. And I will finally show some of the commercialization product. We are using 2 types of concern of the Bale wrap. One is recycled plastic, which is ongoing concern. How can you take recycled and make some commercial product? And second one, how to make biodegradable product commercialized. So I think many people might be knowing. So these are the one research we already commercialized. We took recycled polypropylene. Now we are trying to implement that in recycled LLDP, which is a composition of your Bale wrap. Can we develop some commercial product with our recycled Bale wrap to create some reduce the virgin plastic use and get some innovation and get some value-added application? That's one thing. And so far as the biodegradable, which is already commercialized, I hope many people might have had. So we developed some compostable coffee pod with a circular economy approach. We took coffee shop, which is the industry waste from any coffee industry in the world. This is a no-cost material. So people in the coffee industry were paying money to dispose of this waste. So we integrated this waste and included into costly biodegradable polymer. So this became cost competitive in comparison to the biodegradable plastic. That is the reason this is commercialized today. So whenever we are approaching our biodegradable Bale wrap, that is our approach. How to integrate some waste material into the costly biopolymer? Can we make it cost competitive? The cost is the end of the road is to make a cost competitive, and that's the reason this product were commercialized. And if you see this diagram, you can see the left-hand side. This was what earlier produced by polypropylene, which is a non-biodegradable polymer, and the base of this is made from PT, exactly another polymer made for your bottle polymer. They make some fiber. So this was the traditional coffee pod made by Club Coffee, and now this is the made by BDDC. We have this black color or off color. See, this is a biodegradable formulation, and the upper one is PLA, which is a corn-based plastic. And overall product is cost competitive. That's why it entered into the market. So yes, there are a lot of dialogue going on compostability of those. But having said that, till now, Club Coffee made 1.2 billion coffee pod by now with our technology that's called per pod 100. This milestone represents diversion of more than 3,000 tons of plastic single-serve coffee from landfill in Canada. So well-known brands by President Choice, Maxwell, Noble, Ethical Bean, Mascaco, Jumping Bean, Kraft, and Good Waste are utilized this type of biodegradable formulation. So what is the key message of my today's presentation? Number one, sustainable materials is the wave of the future that may be obtained from biological source, recycled materials, or waste, or combination of that. There are a lot of science and innovation is happening. That's what not only VDDC we are doing. A lot of people are really concerned to how to develop sustainable material. So the main slogan is nothing is waste. Waste should consider the resource for a new industry. Value-added bio-based materials from waste. That waste may be food, agro-food waste, and plastic waste in integration into the final product for commercialization. Certified compostable Bale wrap products can reduce the landfill. So circular economy is a sustainable move that can certainly reduce the plastic waste problem. So I must give my thanks to many industry organizations and for their support, and to the BDDC. I'm also particularly thankful for Ontario Federation of Agriculture and many research we do that also can be interest to the OFA, and numerous government, NGO, university partners, all my students, and also Dr. Mahendra Thimari, who is a part of this Bale wrap project from Amar. He was also very helpful in implementing this project with us. And Don Nutt, who donated us some recycled and clean Bale wrap sample to do some research to find some value-added application of those ongoing problem in Ontario agriculture, although our future aim in this project is to develop some biodegradable water. So thanks very much for everybody for listening, and I am also thankful to all my research group in the center who is really working hard to make some innovations for real world application. Thank you everybody, and I will be happy to take up some questions.
Well, thank you very much, Dr. Mohanty. That was an excellent presentation. We do have just a couple of minutes to answer a couple of questions, and then if we're not able to get to all of them, of course, we will send the questions to you and have the answers available to everyone on the website.
Yes, that's right. Thank you.
The first question I have is, will we be able to have edible Bale wrap or twine, so that could just be ground up with the feed and fed to the animals? Is that something we'll be able to have in Canada?
That's excellent question. Is to make edible film and to make that property requirement and having this sort of properties is a difficult scientific challenge. Yes, we can make in the large scale, but making those edible type of Bale wrap that can be also taken by animal, and that's a very challenging project. So, but at the end of the day, unless a product is cost competitive, that cannot go to the real world applications. We can make it, and we are also developing those type of things that can be made edible, but making edible and making it so tough and making it sustain the lot of environmental concern like rain, water, and all those ice conditions, and in the field for a long time, at least 1 year shelf life of those. It is in my view, honest view, technically it is possible in the large scale. We can make some film that can show you some properties and somebody can edible it, but to make it cost competitive, it will take some more time.
So I guess it's a challenge because of our extreme conditions. So you need to make it so it lasts in our environments in Canada. So it's hard to then make it digestible for the
Yes,
animals too, I
digestible.
guess.
And at the end of the day, suppose you are making something that should be, it should have a environmental stability. It should have stay in the field for the time period that generally bell wrap stay in our field. So this will absorb a lot of moisture and all those. Yes, we can make some coating. We can develop those materials. This is possible technically, scientifically, but to make cost competitive. To my knowledge, nowhere in the world this type of products has been successful commercially.
Thank you.
Possible.
I have a question about biodegradable film. Can it be used for packaging fruit and vegetables or hothouse films or any of that kind of stuff, or are we just looking at things for like bale wrap and that sort of thing?
No. Bell wrap is one of the biodegradable polymer things specifically for this project, but we developed some film for vegetable packaging and so some different type. Vegetables is a very broad word. Suppose you make one vegetable versus another vegetable, the type of plastics are different. But having said that, yes, we are doing a lot of vegetable packaging based biodegradable packaging in our center. And it is possible to make biodegradable plastic and certainly cost competitive because we are competing with the petroleum based plastic, which is quite inexpensive.
Right. I just have one quick last question for you. What is the difference between biodegradable and compostable? So you, so,
Biodegradable.
have you got a few minute answer?
Yeah, that's a very good question. If I will try to give a presentation, it take about half an hour to explain clearly. But to be very honest, in answering your question, many public understand biodegradable means if anything I use, I will use through and outside the road, it will degrade and it will convert completely to carbon dioxide and all those things, and nothing will stay in the environment. That's not true. Biodegradable means it should be defined correctly. Once a polymer is put in the composting condition, having appropriate moisture content and temperature, and if that degrade within a particular time, within 6 months, it must degrade to 90% and above. Suppose you are putting something in environment, it is degrading after 100 years. That the people can also telling biodegradable. What that real sense is not biodegradable plastic. So biodegradable plastic have different biodegradable. Whether they are biodegradable in the in your composting condition, or biodegradable in the marine environment, or biodegradable in the soil atmosphere. So every product has different standard. So biodegradable is not compostable. Imagine if you have a newspaper. Newspaper everybody knows is made of cellulose. It's a biodegradable polymer. But imagine if you put a newspaper inside your landfill. The research has already been done. Even in New York, one of the dump, the newspaper was taken out after 50 years, and people can read that newspaper. So you cannot tell a newspaper is biodegradable if it is put in the landfill. But even newspaper in the moist condition put in the municipality green bin, yes, it will degrade. It is called biodegradable. Or in the composting condition, it is biodegradable. That means it is degraded 100% into carbon dioxide, water, and non-toxic materials at the end of the shelf life. That end of the shelf life is 180 days. If it became 181 days, it is not certified as a compostable biodegradable polymer. So people might claim, oh, my product is partially biodegradable. That's more dangerous. That creates those microplastic. Partial biodegradable is a greenwash. This is some misnomer, and this is in many of the California and other is considered as a law can be taken some action about the people who claim that my product is partially biodegradable. Imagine somebody take a biodegradable plastic, let's say PLA, and they mix with the synthetic fiber, but the overall product, if somebody claim it is a partial biodegradable, that is not true. That's wrong. That's called greenwashing. So that's a lot of legal action has been taken. There are a lot of examples has been happened. So biodegradable and compostable, they are not same. Compostable means it must be biodegradable to 90% and above in 180 days, and no toxic materials will be remain in the soil or in the compost. So that is what.
Well, thank you very much. Thank you very much, Dr. Mohanty. This was terrific. We've run out of time for questions, but I will have some more questions from our question box here to send you, and that was terrific. Thank you very much.
Thank you very much for the opportunity to speak before your esteemed audience. Thanks to OFA again.